Okay.
Yes, Prof.
Okay, thank you very much, Dr. Faizal. Okay, my topic for today is a challenge and assessment of biomass conversion pathway to produce a sustainable biojet fuel in Malaysia. As you know, that the sustainability in the biofuel is one of the hot topics for recent years, and especially various factors are involved. One of the areas that people are very of concerns is the biojet fuel. However, in Malaysia, this topic is still lack of the attention from general publics, because I think that because we are more concerned about our public transport, like our biofuels, maybe for the public transportation, for car usage, but for aviation industry, this is the topic that may be a little bit distant to the general public. However, today I will share some of the general information. I will also share the challenge and what are the potential biomass that can, and the pathway that can convert the biomass into the biojet fuel. So these are the information I will go to share in this section. I hope that you can benefit from the presentation today. After that, first of all, we want to share with you that what's called the global warming. In fact, that the Earth atmosphere is actually warming up. I think most of you know that the global warming is now a current challenge in that all the mankind on Earth are facing. Whether you deny it or you accept it, it think is happening. Yeah. Basically, this global warming effect is actually caused by the greenhouse effect. So we call it greenhouse effect because the atmosphere actually warm up in a similar way like a greenhouse. Yeah, the Earth are covered by the thick layers of carbon dioxide, which we emitted from our burning our fossil fuels and other activities, human activities that cause the kind of blanket on the Earth, keeping our Earth too warm. And why so worried about the global warming? As you can see on this picture, that iceberg actually melt in the water of Antarctica. Climate change accelerates the rate of ice loss across the continent. So it's something that you can't deny that our Earth is warming up. For the last 100 years, the iceberg are seldom melt. But now the rate of melting or Antarctica and Arctic are actually faster than we can imagine. So that is predicted that in the next 50 years, we might not have any ice during the summer in the Antarctica and Arctic areas. So this is quite worrying. And this picture also showing that in the high plain of Bolivia, the man surveyed the big remains of what is so-called the country's second largest lake. And you can see the picture is actually dry out. Now the lake Popo, actually caused by the drought and the management issue that actually make the lake actually dry out. And this is I always like to share this with my students when I'm teaching the atmospheric risk management courses. You can see that the climate change impacting the flora and forest system and the Arctic. Although the scientists don't know specifically what killed this individual polar bear, experts are warned that many of the bears are having trouble finding food as a sea ice historically rely on the thin and melt earlier. I think the food shortage although not only causes by not only affected the animals, but also in future might affect the mankind. So we are actually in the trouble that if we don't try to do something for our Mother Earth. Other than that, you can see that the forest fires, the long drought, and super cyclone, all these are caused by the global warming and climate change. So these things that actually give us a warning that ring a bell to us that we should conserve our environment, especially reducing the carbon dioxide emission to reduce the effect of the global warming. So my focus today is on the aerospace industry. This is an industry that also contributes hugely on the emission of carbon dioxide. Yeah. So general background about the aerospace industry here, you can see that the aerospace industry is a gigantic sector which support nearly 2.7 million jobs, direct or indirectly, and generate about $2.7 trillion in the gross domestic product. So He is also forecasted that the aerospace industry will support more than 99 million jobs, direct and indirectly, with the GDP estimate about 5.9 trillion in the next 2 decades. Of course, if we're taking out the effect caused by the COVID-19, it might be slowed down at the moment. But however, if things back to normal, this is what we forecast is going to be happen. So let's look at our area, Asia Pacific region. It's at about 6% of the compound annual growth rate between 2018 to 2037, estimated by a study from the Airbus. Here, the picture shows the air traffic data on the revenue passengers kilometer over the time and future prediction by Airbus. You can see here the air traffic is expected to be double in the next 15 years. And as overall, 20 years more annual traffic grew of 4.8% is predicted. So it shows that the industry will keep growing and booming in the future. More and more people are using the air traffic as one of the transportation. What about Malaysia? What about the Malaysia scenario? For Malaysia, the strengthening of its manufacturing supply chain and maintenance service are undergoing the transformation with the Industry 4.0 as a catalyst. However, environmental accountability still lag behind in the Malaysian aerospace industry. Even at the tremendous growth of the industry due to the low-cost carrier such as AirAsia, Firefly, Tiger Airways, Malindo, and Jetstar. This is actually quite a concerning issue because as a Malaysian, the industry or public are still lack of the awareness of the taking care of the environmental caused by the aviation industry. So from this figure, you can see the trend and growth of Malaysian jet fuel consumption due to the forecasting growth of the aviation industry in Malaysia. We can foresee that in the next 2 decades, there will be the growth of the industry, and there will be more demanding and more consumption of jet fuel in the next 2 decades. So what's the relationship of aviation industry and the carbon emission? Aviation accounts for roughly about 2% of the man-made carbon emission globally. So global production of aviation fuel, particularly kerosene jet A1, had a market presence of 80 billion gallons per year, or 302.8 billion liters per year. For aviation, however, alternative options to power the aircraft are limited. This is a sad news that we don't have much choice there. We have to use the fossil fuel. Yeah, not to mention any prospective technologies such as batteries, fuel cells, hybrid propulsion, and etc. are still rather immature to have a short-term impact. Yeah, there's a lot of research working on that, such as fuel cell, using hydrogen powers. Yeah, battery, hybrid propulsion. However, this technology is still under development and still in the R&D stage. It's still not established or not mature enough to be a technology that can totally replace the conventional fossil fuel, as well as conventional jet fuel, which is kerosene. Yeah. From this picture, you can see that the carbon emission from the passenger transport. We are comparing various types of transportation. As you can see that the airplane is having the highest carbon dioxide emission per passengers. Yeah, you can see that it consists about 200. It contributes about 285 grams of carbon dioxide per passenger per kilometer. So you can see that as compared to other transport, you can see that airplane actually contribute more carbon dioxide than others. So it's quite worrying to the scientists or to the environmentalists that the impact of the aviation industry to the global warming. So that carbon offsetting or reduction scheme for international aviation, or simply called Crosshair, is a global initiative by United Nations to address offset aviation emission through offset credit and allowance from emission trading scheme. Malaysia have pledged itself toward the Crosshair and implementation phase in 2020. Yeah, this is the Malaysian initiative trying to cut down the carbon emission in the aviation industry. So Malaysia also joined force in the Crosshair trying to reduce the carbon emission. Yeah, it's imperative that Malaysia have offset credit to address aviation emission. One such credit gain could be the utilization of BioJet fuel. It is obliged by the Malaysian government that especially to address the issue of the carbon emission by the aviation industry. So one of the measure that Malaysian government can take place is to utilize the BioJet fuel to replace the conventional fossil fuel, which kerosene, which is used on the airplane. So basically, there are some challenges to the aviation jet fuel. During the Aviation and Environmental Summit organized by Air Transport Action Group in 2008, aviation leaders across the group committed to the industrial long-term plan to improve its carbon footprint. Yeah, and actually, that's not new that the aviation industry actually have their attention on the carbon footprint produced by the airplane by the airplane or the aviation industry. So they actually the leaders of the aviation industry actually come together and try to discuss the solution for this. Yeah, or some any measurement they can take to reduce the carbon emission. The aviation carbon dioxide roadmap pledged the aviation industry to reduce emission carbon dioxide, nitrogen oxide, and noise. This is one of the target that they're trying to reduce. So they have a roadmap trying to reduce it state by stage on the carbon dioxide reduction and also the nitrogen oxide and the noise control. This reduction will achieve through the 4 pillars of innovation, such as the product technology, operation and infrastructure, economic measure, and sustainable fuel. So these are the 4 aspects that they are looking into it. So we today our presentation will more focus on the sustainable fuel. Yeah, here is the 4 pillar reduction roadmap. So if the forecast that with the different measurement, recent action they've taken. So what happened to the carbon reduction? As you can see that if there's no action being taken and business as usual, the carbon emission will be reached the peak by year 2050. So if there's some measurement that have been taken, such as using the biofuel and together with the other technology measurement, you can see that it can be successful. It's predicted that we can successfully reduce the carbon emission by 50% in year 2050. This is what we hope to see, because if we do nothing, that you can see that we will left the global temperature to increase by 2 degrees Celsius, which is not to be what the scientists don't want to be seen, don't want to see, because the 2 degrees Celsius will cause a lot of the damaging to the ecosystem and also to our Mother Earth. So we can see that it's very urgent that we need to control our carbon emission by 2050. Even in the car automotive industry, and the EU also have come out with the next zero emission plan of until the 2050 by the institution or energy agency, International Energy Agency, IEA. So they also have a roadmap, and also the plan for the carbon emission reduction by year 2050. So also happened to the aviation industry. Their target also set by 2050, hopefully can reduce by 50% of the carbon emission in the aviation industry. So seeing that biofuel or alternative fuel might be an option to reduce the carbon dioxide, so it's getting the attention of the aviation industry to focus on the replace the current fuels that used by the airplane. So the evolution from 2007 to 2017 in the biojet fuel arena can be segmented into portions: the upstream and downstream momentums. Okay, the upstream look at the biomass feedstock possible to produce a biojet fuel and how this resource can be developed for a mass scale. Yeah, it is very important. Unlike the car or unlike the lorry or the road transportation, the consumption of the fuel are not as huge. However, for the long distance traveling, for the jet fuel, which taking more passengers, more heavy load, the jet fuel consumption is huge. So we have to make sure that the supply and the feedstock for the biofuel must be enough to sustain the industry. So the upstream industry are very fast focused on that the feedstock, the supply of the feedstock, that enough to sustain the production of the biojet fuel. So the upstream also look at the condition of this feedstock to enable the production of biojet fuel, including the energy densification, biomass treatment, conversion to oil, conversion to intermediate product, and storage. These are all the technical issues that they need to solve before they can put it to be in the practice. So, yeah. So for downstream they actually look at the oil refinery, converting intermediate product into the final form, the jet fuel. Yeah, the product blending, marketing of the fuel, the certificate. So all these things are the downstream industry. The first upstream are to ensure the production of crop, the production of biomass that enough to supply to the refinery. You have to make into the jet fuel. So the downstream are more focused on technology or conversion technology of the jet fuel, and also the quality control, also the certification of the biojet fuel. These things are the focus on the downstream industry in the biojet fuel. Here you can see the comparison, general comparison of bioenergy progression from 2007 to 2017. Yeah, we classified the 2007 in the earlier stage that as of the feedstock time is the first generation. We have discussed all this about first generation, second generation, and third generation feedstock in later lectures. Okay, so basically we classified the 2007 as the first generation. So the oil production are rather low, only about 27.85 thousand tons production. Yeah, and as compared to recently the 2017 production, it had been increased from 27.85 to about 82.31 thousand tons. Yeah, in year 2016. Yeah, the technology transfer also been undergone the transformation. Then the early technology are focused on the Maillard efficient source, and there are more technology have been applied, and with the advancement of technology, more technology are getting involved and more feasible or under development in the second and third generation. Yeah. So the fuel performance also, you can see that there will increase. Of course, the fuel price also being reduced due to the advancement of technology, yeah, and then the improvement of the efficiency of the energy, the process conversion. So here is the basic comparison of the conventional jet fuel and with the biojet fuel. Yeah, you can see that there are pro and con for the biojet fuel as compared to conventional. Yeah, if you take the example of the SPK HEPA, there is a cleaner combustion, more research carried out, this step required and byproduct and less byproduct. However, they also have the limitation of lack of aromatic, more expensive of the three higher capex, feedstock competition, and low yield. Yeah, you see that although there are many currently there are many BioJet fuel have been developed. They also have the advantage and disadvantage as compared to conventional. However, this can be overcome in the future when the technology are further improved. This is basically this diagram to show you the various pathway that to produce the alternative BioJet fuel. I will discuss in more detail in the latest lecture slide. Yeah, basically we have to, you can see here that from the very left hand side, the feedstock of the BioJet fuel are basically consists of vegetable oil, the used cooking oil and fat, algae, liner cellulose, waste gas, carbon monoxide, carbon dioxide and hydrogen, sugar and starch. These are the biological process. They are undergone. So the process of conversion can go through the biological process, chemical process, thermal process, and others process. So the more detail I will discuss it in the later slide. So you can take a glance that there are various alternate pathway to convert the biomass into the BioJet fuel. This diagram shows that the different process that can produce the BioJet fuel. So we will discuss the rest in more detail. Just give you general ideas about this. There are various processes such as hydrothermal liquefaction, catalytic hydrothermal analysis, eddy conversion, gasification, pyrolysis, and substitution. There are various processes that produce the different type of BioJet fuel. So what is the benefit we can obtain from the alternative fuel? The alternative fuel had the benefit to achieve the following: reduce the environmental footprint of aviation industry, which is basically carbon dioxide, sulfur emission, particulate matter, and etc. So they also improve the flight performance, better fuel burn efficiency, and energy contained. Besides the energy security and sustainability, the fossil fuel, you know that the petroleum one day will depreciate. So the plant-based or biomass-based fuel is more sustainable and long-lasting. So which will guarantee that the sustainability of the supply of BioJet fuel. The price stability through the survival of the depleting fossil oil reserve. You can see that currently the oil price due to the Ukraine war and with the Russian, the oil price increased. So by replacing the alternative fuel, they actually can bring down the dependence of the fossil fuel. So indirectly also they bring down the price of the fuel. So then lastly, the utilization of current standing infrastructure. The conversion of the BioJet fuel don't need to build a new facility. They can actually, based on the current facility, the current refinery plant, and just do some modification, and they can be utilized to convert it into the BioJet fuel production. Here you can see that the experimentation of the BioJet fuel surrogate compared to the conventional kerosene. You can see that in the picture A, which is on the left-hand top, that after the combustion with the kerosene jet fuel, you can see that the deposit or precipitation of the particle are very much contaminated the nozzle. You can, as compared, you can see that if you use 100% synthetic jet fuel in or some 2% or 50% jet fuel blend with the kerosene, you can see that there's more cleaner on the engine part as compared to 100% using the fossil fuel. This is also another advantage of using the BioJet fuel. So we can foresee that the performance of the engine will also be improved with the cleaner combustion. Actually, there are airlines they will start to adopt the BioJet fuel. You see, in such as the United Airlines, the Cathay Pacific, Southwest Airlines, the GOL from Brazil, Oslo Airport, the Air France, KLM, Lufthansa from Germany, SAS, Norwegian, and Virgin Airlines. So they in some way they already start to use power the BioJet fuel as part of their fuel supply in their airplane. So by so-called the BioJet fuel are supplied by different producer. Yeah. So it's not a news in the industry that the industry already starts switching to BioJet fuel. Actually, before the MCO, before the COVID-19 outbreak, pandemic, actually AirAsia had communicated with Airbus friend, trying to discuss the potential of using BioJet fuel in their airplane because Malaysia also buying by the Crosshair agreement. So AirAsia will be also affected by 2020, 2030, that how many percent of the jet fuel have to be consists of how many percent of the jet fuel have to consist by the BioJet fuel. So Asia, Malaysia Airlines, they start considering how to implement the blend of the BioJet fuel into the fuel system. So this is also the kind of the opportunity for the industry, especially for the biomass industry, for the refining industry. Yeah. So European European industry actually long before us that had actually started to produce the BioJet fuel. Yeah, because they had foreseen that the demand and also the stringent regulation will be implemented in the next decade. So you can see that the National Oil already start their production by year 2000, as early as 2007. Yeah, followed by other company. You can see that. Yeah, there are more and they are in their future. There are more in production improvement. Such as like BTG, they will increase by 100,000 tons per year in the future. So this is a trend that for the aviation industry and unavoidable that the industry had to face, that they had to use the alternative BioJet fuel in the future. Here this diagram show that there's a chain of biofuel utilization across the different regions of the world. You can see that there are in the North America there are more and more that they use the BioJet fuel as compared to the Asia Pacific. We are slightly far of those we are seem to be improved from as compared to 1990 or on 2000, early 2000. Yeah, you can see that the Asia Pacific also picking up, but as compared to most of the region in the world, the Asia Pacific seems to be a bit far behind. Yeah, the other region in the world of the conversion to the BioJet fuel. Yeah, so this is a bit quite worrying. Excuse me. The bioenergy distribution for biomass material. You can see that the feedstock of the biofuel, yeah, basically the feedstock of the biofuel are from the fuel wood, the linocelluloses, followed by the charcoal, the black liquor from the industry waste, yeah, bioethanol also, and biodiesel, biogas, forest resources, pellet, and the industry resources, and these are hydrogenated vegetable oil (HVO). but this is very small amount there. But there's a potential area in the HVO we are going to discuss later. Yeah, currently most of the biomass feedstock consists of linocellulose base. So you can see here that almost 68% of the bioenergy feedstock actually from the fuel wood, which is linocellulose base. So here this one is show the distribution of the type of biofuel utilized and the distribution of biofuel product on the left. You can see that there are more and most of the biofuel currently utilized are ethanol, which consists of about 74% of the biofuel, and only 4% of the HVO, which is hydro-generated vegetable oil. And United States or USA seem to be the biggest player in utilizing the biofuel energy, yeah, as compared to the rest of the world. Here, the picture shows the distribution of biofuel production over the time. And you can see that the biggest production is still on the North America, and Asia Pacific are actually picking it out. Yeah, here you can see that in our Asian region we are gradually improved, but still a bit slow as compared to European countries and also the Northern American, especially like US and Canada. So how about Malaysia? Malaysia is a country full of natural resources. So that is supposed that we can be assumed that Malaysia is a heaven or paradise for biomass feedstock. Yeah, biomass in Malaysia consists of various types of various categories. You can see that like such as you can categorize them the biomass as a permanent crop and trees, which consists of rubber, oil palm, coconut, cocoa, coffee, areca, nut, varieties, orchid, in the short-term crop, like such as banana fiber, fiber crops, pineapple, paddy, grass, nursery, tobaccos, sugarcane, and such. And horticulture land, mixed horticulture, vegetable, oil, herbal and spices, forest land, the log pile, ex-log pile, forest residues, subland, and other, like for example, the micro and macro algae, waste for animal farm, like dung, cow dung, also things, and minute waste. So all these are the feedstock, potential feedstock that can be used to convert them into the BioJet fuel. So it's here the diagram showing that the potential linocellulose biomass residue in Malaysia with high potential to deem the sustainability. You can see here among the biofeedstock we have mentioned earlier, oil palm seem to be the biggest biomass that have the potential to produce the biofuel and bioenergy for the industry. So our focus might be focused on the biomass from the palm oil. You can see from the study, as compared to other feedstock, the residue from the palm oil palm industry, there will be sent out as the highest feedstock available in Malaysia. So we make a metric against the sustainability criteria. You can see from here, we compare the palm oil, forest resources, paddy, rubber, sugarcane, coconut residue, and palm oil seem to be the most promising feedstock for the biofuel. They are friendly on the land area because of their high yield per hectare land, and they also have the residue ability, government support, and by the incentive, poverty elevation, yeah, and the logistic difficulty are much lesser as compared to others industry. So all these criteria actually have making the palm oil residue as a ideal feedstock for the bioenergy. It is able to compare the various sustainable local feedstock, their respective potential of dry biomass and the BioJet fuels potential. As you can see that the oil palm seem to be the most promising because they have the highest potential biofuel production as compared to other feedstocks such as rubber, sugarcane, coconut, paddy, and forest residue. Yeah. So talking about the liquefied fuel, so here we present a selected oil and the respective yield and area required by the global fuel demand. So we compare the microalgae, oil palm, canola, sunflower, jatropha, and soybean. Yeah, microalgae seem to be very promising since they have the highest oil yield. Yeah, and they have the lessest area request by the global fuel demand. Yeah, as compared to other feedstock. However, the oil palm also stand at the second most potential feedstock for the biofuel production. Yeah, we will discuss that these two feedstock in the later slide. Malaysia actually have once considered the microalgae as a potential feedstock for the biofuel oil. Yeah. There's a lot of research carried out by University of Malaysia, TNB research, and various research institutions on the microalgae. However, most of the technology is still under the development. Yeah, we will discuss why the limitation, the pro and con of this using this few feedstock. Yeah. Okay. At the early slide, we have mentioned that in the 2007 and 2017, there are first generation feedstock and the second and third generation feedstock for that. What are these generation mean to you? The fourth generation word of the biomass derived from the bioproduct. The first generation feedstock and biofuel are generally from the starch, vegetable oil, sugar, and animal fat. The second generation of biofuel and its fixed term are from the need of the non-food-based biomass. To say this is the difference. You see, the first generation feedstock, they basically from the biomass that are considered of food, also as a food. Yeah, that's why there is the issue that the biomass is for the fuel or for the food. So the second generation, we try to switch it to the feedstock that are non-food based. Yeah. And the third generation are therefore entirely on the algae-based biofuel and bioproduct. And fourth generation looking at the non-based biomass destructive solution such as electro fuel, photobiological solar fuel. Most of the research are more on the second and third generation at the moment. Yeah, we can consider the relatively more matured as compared to the fourth generation fuel. So first generation account for the for rise and in food and animal feed price have a negative impact on biodiversity and also compete for water due to the size of the of land is required for the crop to grow. So for the second generation, they provide alternative to food versus a fuel debate. However, itself have its own issue to address such an extraction process from its biomass like sugar, which are locked by the lignin and hemicellulose and cellulose. For the third generation or algae-derived fuel, the major disadvantage is the request of this large-scale imperialization of the algae plant. With other disadvantage involve the balance between the product for fuel and high-value core product, and harvesting and dewatering for the algae and the extraction cost of the oil. So each generation of feedstock have their limitation. They also have the advantage and the limitation to each of them. So our focus are more focused on the second generation. Although the third generation algae and the microalgae seem to be a promising feedstock. However, consider the high cost and competition of the value product that can extract from the algae. So it's not the current consideration to make use of the microalgae. Yeah, because they are also still facing some technical difficulty to extract the oil to ensure that the harvesting process to be successfully implemented. So first generation account for the rise in food animal feedstock. They have negative impact. This one we already mentioned. So basically, this is the pathway of the biomass product. So we have seen the challenge of the faced by the aviation industry by using the BioJet fuel. So how about the potential conversion pathway? The conversion pathway, it means that the converting the feedstock into the intermediate product, then to the product, which is a BioJet fuel. So this consists of the feedstock, which basically from the cross or the crop residues. So to produce an intermediate product such as sugar, biofuel, bio-oil, and intermediate chemical, then as an end product, the BioJet fuel or other chemicals. So basically, there are two major pathway, the convention pathway. So one is by the biochemical and the secondly by thermochemical conversion. Biochemical conversion, the involving the use of biological agent, usually naturally occurring microorganism to convert biomass organic component into a liquid fuel for transportation fuel and gaseous fuel. The common biological conversion is fermentation for ethanol, which is basically the first generation technology. Yeah, in the very early stage of biofuel, people are converting the crop such as corn, corn into a bioethanol. Yeah, and these are very early stage of the biofuel. Yeah, biomass residue first undergo the hydrolysis or saccharification to convert the cellulose component into the simple sugar. Enzyme and or yeast are then add to convert the sugar into ethanol. So this is a very first generation technology. We will go through the biochemical conversion. Yeah. So basically, the process consists of the linocellulose. Yeah, the fiber, the plant fiber, the crop fiber can actually convert into through the pre-treatment, washing, separating, pulping, then the extract, the lining, and also the extract the cellulose. So then they go through the hydrolysis process by the enzyme bacteria, then they convert into a sugar. Then the sugar will further fermented into a ethanol or bioethanol or biomethanol or other product. Okay, so these are basically the process, the description of the process. The other conversion process is the thermal waste. Involve the process of subjecting the biomass residue to elevate temperature. An irreversible reaction where biomass components are converted into a various high energy component in the form of solid, liquid, and gaseous. So basically, this process can consist of like process of pyrolysis, which convert the biomass and with heat into a charcoal and gas and oil, which is also the fuel. Then or go through the gasification process where the biomass is gasified under the limited oxygen supply when made into the fuel gas and or syngas for the combustion process later. So or go through the combustion process when the hot combusted product will be produced. So this is the conventional pathway to produce a biofuel. So before we study the potential pathway, we first look into the criteria requested by the Crosshair sustainability. So what are the Crosshair sustainability criteria for Crosshair eligible fuel? So before we need to produce the BioJet fuel which fulfill the requirement under the Crosshair agreement. So we first need to understand what the aspect that highlighted by the Crosshair for the BioJet fuel. The technical design criteria consists of the high-performance fuel that can withstand a wide range of operation conditions, and also the fuel that can meet the characteristic of conventional jet fuel for aviation with no requirement for different airframe, engine, or logistic infrastructure, and drop-in fuel, mean that you can directly use the fuel into the engineering without big modification. Okay, and also the fuel that meet the exceed current jet fuel specification, which is STM D1655 and STM D7568. For the sustainability criteria, the sustainability design criteria it consists of the life cycle greenhouse gas emission reduction, so that they have to make sure that there's a reduction in greenhouse gas in the long term. So the limited freshwater requirement and no competition with needed food production. So from here, you can see that the first generation feedstock will be phased out because they face a competition with the food. Yeah. So the focus will more focus on the second generation or third generation feedstock. So no deforestation process, direct or indirect land use change. So that's not encouraged to obtain the forest resources by logging the forest. So the feedstock is encouraged to use the agro residues or other crops. Yeah, instead of logging out the forest. So all these criteria should be fulfilled. Yeah, not only producing a jet fuel, we also had to fulfill the technical and sustainable design criteria highlighted by the Crosshair. So here, I would like to present the 4 potential pathways to produce the aviation turbine jet fuel. Before we determine which pathway the most suitable for the BioJet fuel to be utilized in Malaysia, first I would like to introduce the 4 pathways that can convert the BioJet fuel. Yeah, first is a Fischer torque, followed by the hydroprocessed ester fatty acid or HEFA, sugar or synthetic iso, paraffin, SIPs, and alcohol to jet ATJ. So these are the conversion pathway to BioJet fuel that currently available for production of the BioJet fuel. So hydroprocessed ester and fatty acid, or so-called HEFA, it was approved by in July 2011 under the STM G7566 for the use up to 50% of volume in blend with the conventional kerosene jet fuel. So this is a tested and proven method that approved by the STM, American Standard of Testing and Material Standard. Yeah. So the input feedstock of the HEFA is mainly based on the lipase-based feedstock, which is on the oil and fat feedstock, such as vegetable oil, animal oil, cooking oil, and etc. Advantage of this process is it can be easily integrated into the current oil refining process. Integration into the oil refinery will ease the market entry point from a price, return of investment, speed, and reliability perspective, making it highly economical. So as for the industry player, that this is the good news, because they don't need a big investment, since that they can use the current facility to convert the feedstock into a BioJet fuel. So then it means that they can have a more competitive price and more profit and faster return return of the investment. So this is a more encouraging news to the manufacturer of the BioJet fuel. So how about the other technology? Yeah, sorry. Here is a basic diagram showing that how the pathway of the HEFA going. Basically, the liquid-based biomass feedstock using the oil and fat, and will undergo some pre-treatment to degumming or something that so that then followed by the hydro treatment, hydrocracking, then the distillation to produce a jet fuel. Fischer-Tropsch is a technology that usually used in the oil refinery, especially in the petroleum cracking process. But however, it will also utilize in the BioJet fuel production. Fischer-Tropsch conversion process was approved in the September 2009 under STM G7566 for a commercial use of 50% blend with a conventional kerosene jet fuel across the world. So this is also another approved method for the BioJet fuel production. The Fischer-Tropsch fuel are known as the Fischer-Tropsch synthetic paraffin kerosene or Fischer-Tropsch synthetic paraffin kerosene with aromatic. Yeah, as pyrolysis does not yield the desired liquid fuel, most of the Fischer-Tropsch process for fuel is done with the gasification process of a cold natural gas and biomass feedstock. So this process, the feedstock is slightly different as compared to the HEFA. Yeah, the feedstock basically consists of the solid or gaseous feedstock as compared to HEFA, which is basically using the liquid feedstock. So this is the root of the Fischer-Tropsch process. The carbohydrate-based biomass feedstock will undergo a pre-treatment, then followed by the gasification, synthetic or gas production or syngas, then the Fischer-Tropsch process, then the product recovery and hydrocracking, then the distillation process. The last few stages are quite similar to the HEPA. ATJ and the alcohol to jet again is approved under the STM G7566 in the year 2018 recently. It was initially approved for 30% and revised to be approved up to blend ratio of 50% with conventional jet fuel. So one of the key benefits of ATJ is that it can be converted any low-cost feedstock into ethanol that is locally available. Yeah, this is the advantage of the ATJ. However, there are technical risks that when it comes to scaling up, as there are limitations with enzyme biogeneration. Yeah, when it will involve the bioprocess, that will be a bit complicated because biological process somehow their advantage also they are more environmental friendly. However, the disadvantage might be more complicated and also very much influenced by the surrounding, by the pH, by the temperature, and also might take longer time for the production. These are some of the disadvantages of using the biological process. So basically, there's a description how the ATJ working. The linocellulose biomass feedstock will undergo a pre-treatment, then followed by the fermentation process, then dehydration, followed by oligomerization and hydrocracking and distillation process. So these are basically the root of the ATJ or the alcohol to jet processes. Then the last process, that hydroprocess fermented sugar to synthetic isoparaffin, SIP. SIP is a biological conversion pathway done through the sugar fermentation, where the intermediate known as a phenation. Yeah, it is the only biochemical conversion that is certified today. Yeah, SIP is first developed by Ameris, or now under the total French, as known by them as direct sugar to hydrocarbon. So this is a ship process. The linocellulose biomass feedstock will undergo the pre-treatment through the fermentation, separation and purification process, hydroprocessing and distillation. So as compared to ATJ, the process are more directly involved in the biochemical conversion. Yeah. So here is a few readiness level for description and a gate for the BioJet fuel. Yeah, these are multiple levels that to determine that the jet fuel are under which stage. whether they're still under the research technology development stage or reach the certification process or reach the commercial deployment process. Yeah, this is the guideline that to indicate for the indication. So see that the development of BioJet fuel. Yeah, the level 8 and 9 are ready for commercial, and level 1 to 5 is still under the laboratory process or research R&D stages, and 7 and 6 is a proven technology. Yeah, technology proven. Then for the 9 and 8 is a commercialization process. So you can see from here that among the 4 commercial pathway, the fuel readiness level for the 4 process seem to be still mainly under the R&D stage to the technology proven stage. Yeah, still under very much below the stage of the commercial ready. So as the alcohol to jet, they also under the stage of the technology proven stage. Yeah. Also beside that, as compared to these 2 technology, ship having the problem of the resource availability, and also however the alcohol to jet having the advantage that the abundant resources are more available. However, the technology is still under the proven stage, not yet ready for commercial scale up stage. So so left only 2 technology, which is a HEPA and also the Fischer stock. These 2 technology are more proven, actually are more close to the conventional fuel production pathway. So they are more ready, commercial ready as compared to the other 2 technology available in the for the BioJet fuel. So our focus will focus more on this HEPA and Fischer stock process. Here, we do an assessment of the fuel conversion pathway to feasible to be implemented in Malaysia. So as you can see that for the maturity of the technology, HEPA and Fischer stock seem to have a higher maturity of the technology as compared to AGJ and the SIP. Especially SIP are having the lowest maturity of technology. Yeah, for conversion efficiency, HEPA seem to have the higher conversion efficiency as compared to Fischer stock, and the other 2 for ATJ and SIP, they are in the state of medium conversion efficiency. So for the process demand, HEPA is low and Fischer stock is high because most of the conventional refinery technology are using the Fischer stock. They are not more ready for that. So as compared to HEPA, Fischer stock are more ready, available. So, but however, HEPA have the advantage of they have a low process complexity as compared to the Fischer stock, and the potential competitive. You can see that HEPA have a high potential competitive as compared to others. Core product, the HEPA have a high core product as so as a Fischer stock, and the other 2 are either none of medium. Implementation process, we can see that compared among the 4 process, HEPA seem to have the highest implementation potential, and followed by the Fischer stock. ATJ and SHIP are either medium or lower. So we can conclude that there are two commercial road that are pathway that are suitable to be used in Malaysia, which are either in HEPA or Fischer stock. So as a conclusion of the assessment, we can see that HEPA and Fischer stock are 2 most mature process to be implemented in Malaysia, whether through Malaysia's own technology development in country capacity or importing the technology into Malaysia from foreign investment, either by your own development, technology development, or the transfer of technology. Yeah, Fischer-Tropsch wrote there will be insufficient sustainable linocellulose biomass, even we including the palm oil derived residue. Yeah, some might say that we have a lot of abundant empty food branch, a lot of abundant sugar baggage or something, but we still from our analysis. We still found that the fixed stock is far below what they can sustain the production of the BioJet fuel in Malaysia. We have to do a study, which we are not presenting in today's presentation. We have done a study on the Malaysia biomass fixed stock, including all the solid residue from the palm oil industry, sugarcane, rubber, forest residue, wood stock sort of thing. So we found that even though all those what's so-called the solid fuel or solid fixed stock are not able to sustain the production of the BioJet fuel. They cannot supply enough linocellulose for the production of BioJet fuel to convert it into a sugar, then to the bioethanol or BioJet fuel. So then from there we actually phase out the Fischer-Tropsch because this requires a solid fixed stock as compared to the HEFA, which are using the liquid fixed stock. Yeah. So palm oil CPO is considered the direct competition of the food. So the cooked palm oil, we should usually refine it into making the edible oils and also the other products. Yeah. So you might know that the palm oil, the cooked palm oil, will be refined into oilin and solid, which actually for the industry product and also for the food, which is edible oil. So we by considering the HEFA, one of the potential feedstock we first come into our mind is the palm oil. However, we might face the competition with the so-called the food usage of palm oil. So we don't want to have the crisis that we have a shortage of cooking oil. So this might be a trouble. Yeah. So the other potential is using to cultivate the microalgae, the third generation feedstock, or utilize the palm fatty acid distillate, considered sustainable under Red 2 and Crosshair. Okay, microalgae is a potential feedstock for the BioJet fuel, as we mentioned before. It can be served as the feedstock for the HEFA to produce a BioJet fuel in Malaysia. However, as we mentioned also, there are still a lot of technical issues need to be solved before they can make into a big scale of the planting and for the growing and the farming and the harvesting. Yeah, it's not easy to harvest the microalgae and to extract them into the oil and also to separate them. There, in the lab scale, there have been a lot of reporting research output from the lab scale research. However, the commercial scale are still very much underdeveloped. Yeah. At the same time, the microalgae, people also extract the fatty acid from microalgae such as DHA to produce the DHA and omega-3 from the microalgae. So if you're using the microalgae, you might also facing the competition with value-added product such as omega-3 with the production. So at the moment, the microalgae is also not a present option for the production of BioJet fuel. But so the left only one option, that might be considered the potential feedstock for the biojet fuel, which is a palm fatty acid distillate. Yeah, so PFAD. Yeah, this PFAD is actually a byproduct from the palm oil distillate, palm oil refinery process. So in the Malaysia previously, this byproduct actually is a burden product. The industry don't know what to do with them because usually they'll try to convert them into a biodiesel. Yeah. However, now we can use it as a biojet fuel. Yeah, because there are huge amount. The analysis, according to the analysis we have done on the PFAD, the supply or the production of this byproduct from the palm oil refinery industry are huge enough to sustain the supply for biojet fuel production in Malaysia. So PFAD is considered the potential candidate as a potential candidate for the feedstock of the biojet fuel in Malaysia. Yeah. So this is the assessment we have done in our previous study. So yeah. So today we share with you. Actually, we have done further study the economic and technical assessment on the biojet fuel. However, we don't present that because due to the agreement with the Airbus that they asked us to keep the data confidential and not disclose them for 2 to 3 years time. So the process, so at the moment we can't disclose too much about the analysis we done. We have going through a Monte Carlo simulation on the economic assessment of the biojet fuel using the PFAD and also the process assessment for HEFA. And it's proven that the HEFA plus PFAD is actually the potential conversion pathway for the biojet fuel that can be implemented in Malaysia. Yeah, I think I will end my presentation here. Thank you very much for your patience. Pass that back to the chairman. Thank you, Dr. Faisal.
Okay.